Hello, everyone. My name is Connor Fromknecht. I'm the head of cryptographic engineering here at Lightning Labs. I'm pretty excited to be back today because I think last June, a little over a year ago, we were here in Berlin at the Lightning Hack Day, and I think it was the first Lightning Hack Day actually, and a bunch of the team was here, and we talked about three sort of like interesting directions for the Lightning Network, and I think they were watchtowers, AMP, and splicing. Since then, we've kind of deployed watchtowers, like an initial version of that on the network, so that's pretty exciting. And to be a year later and making like tons of progress in terms of the spec and sort of proofs of concept of multipath payments and AMP is pretty exciting. So today we're gonna explore kind of like the multipath payment things coming to Lightning and sort of how that's progressed in terms of the spec, where we are in terms of implementing it, maybe like a sort of like a rough deployment timeline. And yeah, let's dive right in. So let's say, so to address sort of the problem that multipath payments solve, let's say we have this network. We have Alex trying to pay Fold through Brian, Carla, Desiree, and Elizabeth. And currently today, when you want to make a payment, your payment is tied to one HTLC. This is sort of the only payment type we have today in the Lightning Network. You get one HTLC, you send it to the recipient. If they have an invoice, they send you back the preimage if the amounts match. Now, Alex is able to send along this top route 3 BTC, and along the bottom route, he can send 5. The reason that is because those first channels that are connected to him are sort of the minimum amount along those paths, and that sort of caps the maximum amount of capacity or the max payment size he can send in that direction. And this presents a couple issues, especially in terms of UX. So for Alex, his maximum amount that he can send is the maximum size of the channel that he has connected to him, which in his case was 5. Sort of like on the flip side, you have the maximum receiving capacity is the maximum sort of inbound capacity you have. So for Fold's node on the right, on the previous slide, that was 8 along that bottom path. And that's kind of confusing for a lot of people because you'd think that if I just have a Lightning app and it shows a Lightning balance, that would be like, if I have $2,000 in my bank account, I should be able to send $2,000, right? Not so with today's Lightning, and that's because you're sort of limited to this path constraint. Like we get this question a lot on Slack. It's like, I have 3 channels with 1 Bitcoin, why can't I send 2? And that kind of leaves users like this. And so what is it that we want? We want people to have this sort of idea, like in terms of a better user experience, that I have a balance, and that is the amount I can send. And similarly, like if I have all this inbound capacity, that's how much I can receive. So we want to like bump up these limits. So today we are limited by sort of these max local and remote balances of a single channel that you own. We want this to be more of like, I want to be bound by the sum of all the local or remote capacities that I have. So it's the similar case for the remote. And what this leads to is more of a unified Lightning balance, like I said, both for sender and receiver. And to me, this is pretty exciting because in addressing this problem, I think it will be sort of one of the biggest UX improvements from a protocol perspective that's like on the near-term horizon that we're working on in Lightning. So to go back to our diagram, how do we fix this problem, right? Alex is able to send 3 along the top path and 5 along the bottom. And what we want to do is be able to take sort of all of his available capacity along every path all the way to Fold. The problem here, for those who are familiar with like more of the computer science stuff, is that the max flow through this graph from Alex, who's the source, to Fold, who's the sink, is that when you only take one path, there are many, many other paths that can also add additional capacity that you aren't taking advantage of. And so what we want to do is be able to say Alex could send both 3 along the top and 5 along the bottom at the same time in one single payment. So that is sort of where we came up with this idea of like a multipath payment. What if I can make multiple HTLCs for the same payment that then are all sort of one logical payment and settle as if they were all sent along, let's say, a single path. So that kind of brings us to where we are today. There are many, many different types of multipath payments since I think we first kind of proposed the idea back February 2018. And since then, there's probably 5 or 6 different sort of like flavors, if you will, of multipath payments. The first one is kind of like, my acronyms might be a little bit different from what you see on mailing lists and stuff like that. So the first one is multipath payments, is what I'm going to call it, which is also referred to as base AMP. There's a proposal for this on the spec right now. This is more or less kind of the most logical next step from like single shot payments. It uses like, in the same way that a regular payment, you get an invoice from the receiver, it has a payment hash, I make a payment to that payment hash and then receive a pre-image. This is sort of the direct translation where you just say, I send n HTLCs, and then the receiver kind of waits until they all get there, and once it has enough that settles the invoice, they send a pre-image back along all those paths. So that's like I said, the most direct. Like all the UX metaphors that people have developed around like proofs of payment or whatever, those all carry over to this style of multipath payments. The next one is what we call like atomic multipath payments, or AMP, and that is sort of really a bigger departure from this like MPP or multipath payments. The main reason being that you don't actually get a pre-image back. There's sort of this concept of like, oh, I paid, I got the pre-image, that means I paid. In this variant, that's not the case. What happens is the sender is actually generating all the randomness for pre-images and hashes for all the HTLCs that it sends out. If the receiver gets payments that sum up to the total of whatever invoice they have, then they will just settle. But the sender learns nothing new because they generated all of the randomness. And this is done, this sort of like the way that you get n of these payments with different payment hashes to be sort of one unit is we use like this additive secret sharing technique, where once all the payments have arrived, the receiver has enough information to actually sort of reconstruct the pre-images and send them back, and I'll get more to that later. And then a final kind of flavor that I won't talk about as much today is the sort of discrete log multipath payments. These will kind of come around more once we have Schnorr widely deployed. You can technically do them today using 2P ECDSA channels or any sort of those like threshold or multi-sig ECDSA. But this is sort of after a world where we've replaced payment hashes with elliptic curve points, and you're actually sort of like making a payment to a public key, and you eventually learn some secret. These are probably it's undeniably like the coolest form of multipath payments that you kind of know of today, but they're kind of a little farther off, so we're going to spend more time on the first two, which are like kind of more realistic in terms of like a future timeline. So the cool thing about the discrete log multipath payments is that you can kind of take the best of both worlds from the regular multipath payments and the atomic ones. And that is because you can both, the atomic multipath payments, all the HTLCs are different hashes, so it offers more privacy because you can't correlate that these different HTLCs are for the same payment. And you can do that here. And in fact, even an additional step beyond that is that each hop actually sees a different bit of or a different random public key or hash, let's say. So then you can't even tell if you go in a cycle that they're the same payment. You can also do, you can optionally do this sort of like pre-image reveal technique. So like I said, in the multipath payment, you actually get a pre-image back, sort of like how Lightning payments work today. But the atomic multipath, you don't, because the sender already knows it. In this discrete log case, you can actually do either one. You can either choose not to, or you can have the sender sort of reveal this private key to you in the process. So it's a lot more composable when it comes to integrating this with other, maybe more there's a lot of other composability you can do with Lightning payments, like on-chain HTLCs, loop, those variants. And this is all enabled by this sort of additive homomorphic secret sharing, which if you're interested in this, I would highly suggest reading the Atomic Multi-Hop Locks paper that Pedro has been presenting over the last year or so. So let's do a quick dive into kind of how these things work. So for those of you unfamiliar with all three implementations this year deployed what we call this TLV library or serialization format. And that enables, it's kind of like a key value dictionary that can be serialized efficiently. And we kind of use that to add extensibility to all of our wire messages, onion payloads, stuff like that. So we're going to add a new sort of MPP field for the final hop. And when I send out multiple HTLCs for this multipath payment, I'm going to include the exact same one of these fields in all the payloads to the recipient. These fields have two things in them: the total amount of the sum of all the HTLCs I'm sending out, and then this payment address, which is more or less just to prevent other people from trying to collide with your payment, since there are multiple. It's just like a random identifier that keeps them, the receiver can basically unsort them if people try to collide with your payments. But the thing you want to worry about is the total amount, because that, once I send out n HTLCs, the receiver gets them and waits until he has what is claimed in all those payloads, and then he settles them as one. On the right, you can see sort of some simple logic for basically optionally including that payload into the final hop's onion. And like I said, the receiver waits until he has a set of HTLCs. that actually add up to the total amount, and that total amount will be the value that's in the invoice. So just like before, if I make a payment in the single shot case and the amount is too low for the invoice request, you could like reject that payment. In this case, if the total MSAT is like too low, you would just reject all the HTLCs. But if it matches, you'll wait until they all arrive. And again, the sender will actually settle with the preimage, and the sender is able to learn that and have this sort of like proof of payment. So building on that, we have AMP, which is the proposals at the moment are kind of going on at the same time. So Rusty is sort of championing the first one we just talked about. I have a proposal currently to do this, and they're very similar in a lot of respects. So they're kind of going on concurrently in the spec process. And basically, you can think of AMP as adding additional fields onto that protocol that we just talked about. One of the main differences is, like I said, the sender supplies all the randomness. And that means that I will not learn any preimage. For some people, this is a bigger deal than for others. There are arguments for and against, but to me, I think, so that is probably the one trade-off the one downside, I guess what some would say to this approach, but you unlock a lot of really cool features in addition. One is that the invoice becomes reusable. If I'm generating the randomness every time I want to pay, I can do that endlessly and continue to pay this invoice, right? If the receiver has to generate a preimage and then give it back to me, I can't use that invoice anymore, and to pay again, I have to actually contact them to generate one and give it to me. But if the sender is generating the randomness, then I can continue to reuse this multiple times. Again, you also get this sort of like, it's a little bit more private because you can't correlate sort of these sub-payments with just by looking at their payment hashes. And we'll get to a little bit into more why those are, or how we actually derive those. And finally, I think this is probably one of the most requested features that I've seen on Slack, and just like in people talking to me in person at meetups, is this idea of spontaneous payments, or what Roast Beef calls key send. And this is the idea where you don't even need an invoice at all to make a payment. I can just sort of send an HTLC to some node's public key, and they can either choose to accept or deny this sort of like donation, this HTLC that came out of nowhere, and I'm just going to choose to accept it. In case you're curious, this is kind of what we have as sort of like this AMP record, AMP TLV record. This set ID sort of functions similar to that payment address or whatever on the prior slide, just to sort of like, if I'm making concurrent payments to the same invoice, remember these are now reusable, you want the receiver to be able to like say like, oh, this is part of payment 1 and payment 2 if they're going at the same time. So we can kind of like unbundle them if they arrive out of order. The root share is, the things to note on this is the root share and the child index, and we'll see on the next slide how those are used. So if I'm going to make an AMP payment, I start by generating sort of 32-byte random values. We call these root seed shares. And these are going to go in that TLV record, in that root share field, for every HTLC. They're all different and all random. The sender can calculate a root seed by XORing them all together. So that's sort of like reconstructing them. And then he'll actually take the child index, which was that last field in the record. So you see the S1, R1, S2, R2, S3, S3. So the child index is like the 1, 2, 3s. And using that, the receiver can sort of like take this value R and the child index and derive down each tree. So what the sender does is it basically derives this whole tree and then makes HTLCs with all the child hashes. It pays out to those child hashes. Then once the receiver gets all the HTLCs, it takes those S values at the top that it got in the payload, XORs them together, and then rederives the preimage, so like the second to last step. And using that, it settles the payment. And so the key here is that once all these sort of subpayments have arrived at the destination, or until all those payments have arrived, they don't know the actual shares, and so they can't actually do this reconstruction and derive all the preimages. But once they do, that sort of like unlocks the receiver to be able to do that. So now I'm going to go into like a little bit more of like a classification of these different payment types. So like I said, today we kind of have one payment type on the network, and within the next couple of months, we'll probably be adding another 6 or so, according to my taxonomy. One of the interesting things to note is that all these multipath payments have a base case of one payment. So I can make an AMP payment that only has one HTLC, And so what you can do is you can replace our existing single shot payments with these schemes and share all the logic. So it's much less code pass. It also is a nice entry point, so where you don't have to add all this like multi-receiving capability on the sender to start making use of these like features. And really the way that this taxonomy breaks down, one comment on that last point is that more or less the general agreed upon direction is as we move forward, like this current payment, this payment type that we use today will probably be deprecated in favor of just always using this MPP or AMP as like your standard payment type, even if you're only making a single HTLC. So who generates the HTLC preimages? We saw in that first type, the MPP or base AMP, that this receiver generates them, and then it's transferred, the payment hash is transferred via the invoice. In the AMP one, the sender is generating them doing this crazy derivation tree. The next question is, does the sender need an invoice? We talked about sort of this ability to do spontaneous key send payments, and that also kind of has to do with whether or not there was an invoice involved. If you have to do this sort of receiver-generated preimages, then you are going to require an invoice. But in the case where the sender is generating them, you kind of have this optionality to have the invoice for tracking or generate them as you, or sort of, excuse me, or generate them as you need and just send payments in this sort of a spontaneous world. And finally, is the payment actually single or multipath? And so what that brings us to is this chart. So, so on the first column, you have sort of that first payment type we talked about, the multipath, like base AMP. The second column is sort of the AMP with the secret sharing and all that derivation tree. And the final column, key send, is AMP but with no invoice. So, and again, all of these have sort of two flavors, where it's single or multipath. And just to kind of go through these acronyms that I made up, we have, and the first one is like pay to one-time invoice, and below that, multipath pay to one-time invoice, pay to recurring invoice, multipath pay to recurring invoice, and then pay to node key, multipath pay to node key. So I just kind of made these up to kind of simplify it. But yeah, I think this is kind of an interesting way to think about it. And these are sort of like 6 different payment types that'll probably be deployed, like I said, in the next 3 to 6 months, I would guess. Don't hold me to that. And so just sort of like a logical progression of how that might roll out. Probably start with like pay to one-time invoice, just like using the multipath payment, MPP records and stuff to deploy single-shot payments. Then you would sort of do this pay to recurring invoice if you wanted to have like a simple subscription service where you're sending single HTLCs. This is super useful. Some exchanges have requested like this ability to have like a deposit invoice and a withdrawal invoice that you can like just pay endlessly to or withdraw endlessly to. And that's nice because if you have these sort of recurring invoices, they can also act as like an account where they track every HTLC that the exchange has ever received from that user. Or like you as the user can see every payment that you've ever withdrawn from the exchange. Again, you can also kind of do subscriptions with that. This pay to node key, which is going to be, tip.me, you want this. Tips and donations, you can sort of like, without any coordination, I can just pay any node on the network, as long as assuming they have like, mostly if they're public, you can do private via some other roundabout ways, but they're very cool because they can basically allow you to do this without having to get an invoice first. And that is kind of more like along, maybe I have a contact book functionality where I know the person's pub key and I just like try to send to that and I can just keep doing that sort of like Venmo style. And finally, like you'd have sort of like adding the multipath receiving capabilities. This is kind of cool because it effectively skirts a lot of the max HTLC sizes on the network currently at the moment, because you have that one-to-one correlation that limits the basically effectively the total payment size you can make. But now if you can make, if you can shard those payments, you can sort of get around that limit by, horizontally, let's say. This will be cool in the MP2OTI case for loop in and loop out. This is really, really cool because I can do a single on-chain transaction and balance multiple, like all of my channels all at once. Either like I pay out of them or receive into like multiple channels, so you can really amortize the on-chain cost there. And then finally, you kind of end up with this deploying these MP2RI and MP2NK last. And I would probably expect the like multipath receiving to kind of be interleaved somewhere along those first 3, just because we already have a lot of proofs of concept in terms of code and stuff like that. But this is sort of like a logical progression of how that might go. So if you guys weren't bullish enough on Bitcoin today, bump it. All right. I think we're out of time for questions, but thank you.